Because we've chosen such long names, we'll just expand to get a little bit more room. And hook up axis 5 to our manual lifter speed command and button 1 to our manual lifter override. If we had other loops that cared about the information from the Tele-Op, then we could add those values into our command signal type def. They could be other speed commands, they could be other override commands, they could be any other information. But the key thing to remember is that only the Tele-Op can write to the command signal. So every time Tele-Op runs, it's going to read not just axis 1, 2 and do an arcade drive, but it's also going to put button 1 and axis 5 into this global. So what we need to do now is read this global in our mechanical lifter and do the appropriate action. So let's just copy that global variable while we're here. Save and close our global data, open up our lifter sub-VI, go to the block diagram, and paste our global in. It's important to remember the global must be read inside the loop. Remember that global value can change anytime. If it's outside the loop, it's only going to be read once the first time this VI runs. So it's got to be inside the loop. And we may very well want the digital inputs to still be read, because that's going to be important for our dashboard. So we're not going to case out all of this. But we are going to case out our state machine. Let's make a little bit more room on either side of our state machine. Bring our global over and extract those two values. We have a speed command and we have a manual override. So if the manual override is true, basically we want to disable our entire state machine. So let's put a case structure around our state machine. If manual override is true, then we don't want any of this to execute. So this code, which has automatically been placed in the true case, we actually want to flip it by right-clicking and say make this the false case. So now if override is false, it will do this. If override is true, then we want to write to the motor this speed. So let's just snag a motor speed command, put it in the true case. We've got our device ref here. We've got our speed here. And let's add a bundle by name, just so we can be consistent of the behavior of the system in manual mode and in automatic mode. Let's put the current motor speed into our cluster. And let's do one other task. Let's set the lifter state to be start. Now, why would we want to do that? Well, it's important when we go into override mode and when we come out again to know what state we're in. If we're up, we don't want to think we're in the down state. If we're down, we don't want to think we're in the up state or waiting for ball. If we put the lifter into the start state here, then if manual lifter override went false, when we came into this case, we'd immediately automatically go back to the start case, which means we could start our sequence again from a known position. So it's really important to take care of this kind of housekeeping behavior when you're changing things based on external values such as the command signal. The real value of this, the reason why we went to all this effort, is that the only place in our entire code where the manual lifter speed is set is in the lifter state machine. We could have had special case code in our Tele-Op.vi that performed this action, but because it's here, it's going to be a lot easier to debug and keep track of what happens. And the other benefit is, because we left our global variable here for our lifter type def, and because we're still writing in the values of our two limit switches and our ball sensor, then if we look back at our robot main and the debug dashboard, these values will still be accurate and correct. There's another benefit to all this. I prefaced most of these statements by saying you should only ever write to the command signal via the Tele-Op.vi. However, there is one other place where it would be okay to write to the command signal. Can you think of what it is? It's the autonomous VI. Remember that autonomous and TeleOp will never both be running at the same time, so you don't have to worry about a race condition. Imagine if all of your complicated, time-critical code was external to the TeleOp VI and was getting commands via the command signal global. It would then be very easy via your autonomous independent VI to write to that command global, and essentially all of the loops will behave exactly the same way whether or not you're in autonomous or teleop mode. So this approach, using the global variable as a command signal, makes it possible to have exactly the same code running whether or not you're in autonomous mode or you're in teleop mode. And that is a real advantage. So, to recap, we took the state machine which we created in a previous exercise to control a theoretical mechanical lifter out of the TeleOp VI and turned it into a sub-VI which runs at the root of the robot main. The reason for that was so that we could ensure that it had consistent timing and ran without a lot of other things slowing it down. Then we added a global variable which made it possible to export the values in its internal typedef so that they can be read by other VIs and by our debugging dashboard. And then we discussed the concept of the command signal global, which sends commands from the TeleOp VI to any of the other sub-VIs, and pointing out that you must make sure that the global doesn't get written by multiple places, but it can get read by multiple places. And finally, we talked about how we can use this approach to make sure that our autonomous code and our TeleOp code don't have to have separate sub-VIs and separate behavior. Thank you very much for watching this video. Remember that these introductory videos are intended to get your feet wet and get you introduced to LabVIEW. There's lots to learn about LabVIEW, and we're very proud of the lvmastery.com online learning experience. We've had a lot of great feedback from other FIRST team members and other high school students who have taken the training. I'd also like to mention the Buy One, Give One special offer for mentors, teachers, and parents associated with FIRST teams. We're allowing anyone who's associated with the FIRST team to purchase the LV Mastery online training for the academic price of $500 for all 3 courses. And for anyone who takes us up on that offer, we'll donate a training seat to a member of their team as well. Thank you very much for watching. This has been Ben Zimmer from lvmastery.com. Bye for now.